Okay, so we are on page 121 of the note spiral. This is page 121 of the note spiral. I highly recommend that you have also open to page 120, which is your recipe for success, because you need to follow that recipe for success. It is the step-by-step procedure to make an A, is what it is. So we are going to occasionally pull that over, but I'd make sure you have it off to the side and recognize that we're following it step by step. So we're going to go ahead and read this thing. It says a publishing company has just published a new college textbook. Before the company decides the price at which to sell the textbooks, it wants to know the average price of such textbooks in the market. The research department at the company took a random sample, this is important, of 36. So we have N equals 36 textbooks and collected information on their prices. The information produced a mean price of 70.5. For this with a sample standard deviation of 4.5. So mu is 70.5, or excuse me, I said that wrong. X bar is 70.50 because that came from the sample. And we have a standard deviation of the sample, which is S of 4.5. And it says construct a 90% confidence interval for the price of this type of textbook. All right, so the very first thing we need to do according to the recipe is define the parameter in context. And so in this case, mu equals the true population mean price of textbooks. Technically of college textbooks and college textbooks of this type, but this is going to be good enough. The next thing we need to do is conditions. And the first conditions we need to address is random sample. Well, the first one, random sample, turns out they told us it was, and I've never seen one where they didn't. If they don't, you're going to need to say random sample is assumed. Random sample given, and I'm just going to make a note that N equals 36. All right, they told us there was 36. Number two, the information, the next thing we need to do is condition number two, which is less than 10% of the population. So we need N is less than 10% of the pop. Here's where we're going to check it. We're going to take 36 divided by 0.1, and that equals 360. And we're going to say reasonable to assume that there are at least 360 textbooks of this type. At least 360 textbooks of this type. Now, the reason we do that is it's a test for independence. You don't need to write this down. I mean, you don't need to write this down on your test or anything, but this is a check for independence. And I'm going to go ahead and write check for independence. And here's what I mean. We used to talk about this giant pile of M&Ms, and I would draw one and I would eat it, and the percentage of colors changed. But it changed so minimally, we didn't worry about it. We said it was close enough to being independent that we didn't worry about it. Well, here we said, you know what, as long as it's less than 10%, we don't worry about it. All right, so as long as you're only sampling less than 10%, we're not going to worry about it. And basically that's implying that we are not replacing, or we're not, and if we think about this, if I was doing a sample of people, I wouldn't want to test the same person twice. So I'm not replacing them back in the pool. So technically it's not really independent, it's independent enough. All right. Then the next thing is our test for normality. Well, in this case, they didn't tell, if they tell us the underlying distribution is normal, we're good to go. But in this case, N equals 36. So the distribution of sample means is normal by central limit theorem. I sure hope I have enough room to write everything I need to write on this problem. All right. The next thing says write the equation. Well, our equation is simply x bar plus or minus t star s divided by the square root of n. And I already know that x bar is 70.5, s is 4.5, n, I'll go ahead and label as 36. What I don't have is t star. So I'm going to go ahead and start plugging in what I do have. What I do have is the 70.5 plus or minus. I'm going to leave a space for t star. S is going to be 4.50 over the square root of 36. So I need to go back and calculate t star. Well, t star is going to be centered at 0. Centered at 0. And we're doing a 90%, so I need 0.90. By the way, alpha in this case would be 1 minus that, so alpha is 0.05. It didn't ask for it, but just we can't do it. And I'm going to be looking for a lower and an upper bound, but first off, I need to get my t star base centered at 0. So my degrees of freedom is going to be 36 minus 1. So here we go to get our t star. Second vars, inverse t, parenthesis 1 minus 0.90, close parenthesis, divided by 2, degrees of freedom, 36 minus 1, or you could just type in 35. And we get a t star of about 1.6895. 1.6895. Now, technically, I need to do 70.5 minus this, and then 70.5 plus all of this. But fortunately, the calculator will do all that for us. If we go to stat test, and we're going to go to t interval, which happens to be number 8, and my x bar in this case, my sample mean was 70.5. My standard deviation of the sample was 4.5. My sample size was 36, and I wanted a confidence level of 0.90. And when I calculate that out, I ended up getting my interval, and my interval is 69.233 and 71.767. This is my lower bound, and this is my upper bound. So we have that done. So the next thing we need to do is we need to write the conclusion, and whether they ask for it or not, you always have to write the conclusion. There's a sentence at the bottom, and follow that. It says, our confidence level was 90%, 90% confident that the true population mean, and what did we write? True population mean price of textbooks. Lies within the interval and then we write our interval, 69.233 and 71.767. Now, they didn't ask us this, but we're going to do it, which is number 12. It says, what if they had asked us to interpret the confidence level? Well, what was our confidence level? Our confidence level was 90%. And when they ask you to interpret the confidence level or the meaning of it, it just means this. In repeated sampling, we are 90%, excuse me, we expect to capture the true population mean of textbook prices %90 of the time. All we did was just brag. We just said, hey, our method is so good, 90% of the time it works. What about yours? All right, that's all we did. All right, and repeated sampling. So in other words, if we did it over and over and over and over again, on average, we'd expect to capture it 90% of the time. Okay? Use the above problem to calculate a 95% confidence interval for the textbook. We've already done all the conditions, so we're not going to go back and do that. We're not going to go redefine it, but I am going to rewrite the equation, which in this case is x bar plus or minus t star s divided by square root of n. The more you write it, the more comfortable you are and the faster you'll get at it. We're centered at we want a 0.95, so we're looking for a lower bound and an upper bound. So plugging in, we know that our mean is 70.50 plus or minus. We'll come back to fill in T star in just a second. S was 4.50, and N in this case is 36. So I need to calculate my T star. Second vars, inverse T, clear, parenthesis, 1 minus 0.95 divided by 2. 36 minus 1 is still the same, and we end up getting a T star of 2.0301. And then I'm going to rerun this thing, stat test T interval, which is number 8. And I just need to change my confidence level to 0.95. And I end up getting an interval of 68.977 and 72.023. My previous interval was 69.233 and 71.767. All right, so this one is a little bit lower. The lower is a little bit lower, and the upper is a little bit higher. This is a little, 68 is lower than 69, 72 is higher than 71. So we got a little bit wider. Why? Because we went from 90% here to 95%. So as we increase our confidence level, our interval gets wider, everything else remaining, if we have everything else remain the same. Then we have x bar plus or minus t star s divided by square root of n. Our drawing is going to be essentially the same, but now we're going to 90%. Or excuse me, 99%, excuse me. So because we went from 90 to 95, we got wider. If we go to 99, I'm expecting even a wider interval. Once again, we have 70.5 as our best estimate, is our sample mean. We'll come back and calculate T star, and we know we're working with 4.50 over the square root of 36. So calculating our T star, second vars, inverse T, parenthesis 1 minus 0.99 divided by 2, degrees of freedom 36 minus 1, and we end up getting 2.7238. And we're going to go ahead and run this whole thing by going to stat test, and we're going to do a T interval, which is number 8. And I need to change my confidence level to 0.99. I'm going to go ahead and calculate. So I end up getting 68.457 and 72.543. And we can see 68.4 is less than 68.9. This is a little bit higher. So we did, in fact, get higher, get wider. So what do we notice as CI, or excuse me, as the confidence level increases, the interval width increases. And just from a logical standpoint, that makes sense. If I'm 90% confident, I'm saying, oh, what are the grades? Oh, if you tell me I have to pick one value, I think the average is 86. Okay, I want you to be 90% confident. Probably between 88 and 84. I want you to be 95% confident. The more confident I am, the wider I want to. If I want to have to be 95, I'm going to want a wider interval to be more comfortable. All right, so this is page. This is the scenario on page 121. We will do the next scenario on the next video.